I am late for my show. Now I have to grope about in dark to get to my seat. Luckily, my ticket tells me to head to row P in balcony. Wouldn't it be nice if there was an equally easy way to locate and classify chemical elements? Well, there is. Join me for today's episode and find out more. Hi, thanks to my cinema ticket, I didn't have to step on to too many toes to reach my seat. This is because the theatre had been divided neatly into blocks of clearly marked rows. In the world of chemistry, we have a system that is quite similar, and it is called the periodic table. On today's show, we will be studying this periodic table of elements more closely. Today we will discuss the 4 blocks of the periodic table. We will understand the position of inner transition metals as we study the 2 rows of 14 elements placed below the periodic table. We will identify the position of metals, non-metals and metalloids and round it off with sample questions and exam tips in the exam decoded. I am sure you are all familiar with the structure of an atom and the arrangement of electrons around the nucleus in orbitals known as s, p, d and f. These are present in shells represented by n, which is called the principal quantum number. If n is equal to 1, the atom only has an s orbital which can have a maximum of 2 electrons. If n equals 2, it has s and p orbitals with a capacity for 8 electrons. In case of n is equal to 3, it has s, p and d orbitals which can have total of 18 electrons. What if n is equal to 4? The atom will have s, p, d and f orbitals and has the capacity to accommodate 32 electrons. Now, depending on the number of electrons and types of orbitals in an element's atomic structure, we classify the periodic table into S, P, D and F blocks. Here you can see S block, which is in yellow, P block in green, D block which is in grey and F block represented by pink. Feeling anxious about how you will manage to remember so much for your exams? Don't worry. Just remember that if you have grasped the basics of how an atom is structured, you can easily master the periodic table. Now let's take a closer look at it. On the extreme left, we see 2 vertical columns called groups. They are in yellow and comprise the S block. As you can see, there are 2 elements per horizontal row called period. On the extreme right, we see the 6 groups of P block elements from group 13 to 18 marked in green. In the very center of the chart, we have 10 groups in the D block marked in grey from the 4th period onwards. At the bottom, the 2 pink rows of 14 elements each are called F block. Elements in a particular block are a bit like you and your classmates who belong to the science stream and only study science-related subjects. Now, students in a different stream, like the arts, are identified by the fact that they study completely different subjects. Elements of a periodic table are exactly like that. Their position in the periodic table says a lot about their properties. Let's first go left to the S block. Think back to what we already know about S subshells.
S subshells are spherical and can accommodate only 2 electrons. Based on this knowledge, it is easy to deduce that S block elements have configurations of either NS1 or NS2. As they have only 1 or 2 electrons in the nth shell or the valence shell, they exhibit a valency of either 1 or 2.
Elements with NS1 configuration of their outermost shell are called group 1 or alkali metals. Please note that hydrogen is an exception.
Elements with NS2 configuration of their outermost shell are called group 2 or alkaline earth metals. Again, this is with the exception of helium. Helium is not an alkaline earth metal.
Now, can you tell me why the S block has only 2 groups? That's easy. It's because the S subshell can only accommodate 2 electrons. All this talk of periodic tables reminds me of one of my favorite periods in school, break time. So I am going to take a short one while I leave you with this teaser. Helium does not have any p orbitals, but it is still placed in group 18 of the periodic table. Why? Keep guessing. I will return with the answer after the break. Welcome back. Before the break, I had asked you the question, why is helium placed in group 18 in spite of not having any p orbitals? And here is the correct answer.
Helium belongs to the S block as per the electronic configuration, but it has a completely filled valence shell. So, it behaves like an inert gas and is positioned in the p block along with the other group 18 elements. Think about that the next time you see those helium balloons.
Let's return to our periodic table. Moving on to the p block of the periodic table, try to visualize the atomic structure of elements with p orbitals. What can we say about their electronic configuration?
We know that they have electrons in both s and p orbitals, so they have an outermost electronic configuration ranging from NS2 NP1 to NS2 NP6. On the periodic table, you can see that they occupy groups 13 to 18.
The groups 13, 14 and 15 are named after the first element. Can you guess the names for them? That's right. You have the boron family, the carbon family and the nitrogen family.
Group 16 elements are called chalcogens and group 17 is known as halogens. Think of all those halogen lamps in all those huge tents for a wedding function. Which elements do you think are used in them? Group 17 elements, of course.
Now we come to an extremely unique group in the p block, group 18. These elements are called noble or inert gases. This is because they have a complete octet in their valence or outermost shell, whose configuration is NS2-NP6.
Now take your thoughts back to the legendary Nawab, Wajid Ali Shah of Awadh. He reportedly had an army of 1700 personal servants. Obviously, he wasn't a great believer in doing his own work, much like our noble group 18 elements. But why are they so unreactive?
You all know that a complete octet in the valence shell signifies a stable configuration. This means that the elements do not give or take electrons easily and are extremely unreactive.
we can get the number of valence shell electrons of p block elements by subtracting 10 from the group number of the element. In p block elements, the number of valence electrons varies from 3 to 8.
Time now to take a look at the D block, which occupies 10 groups between the S and P blocks.
D block elements are called transition elements.
Okay, you have had enough practice by now. Tell me what the atomic structure for these elements would be like. Elements of the D block have electrons in S, P and D orbital. They have the general outer electronic configuration n-1d 1 to 10, ns 0 to 2.
Have a close look. You will observe that the ultimate n shell and the penultimate, that is n-1 shell, are incomplete. Based on the d orbitals of n-1 shell, the D block is classified into first, second, third and fourth transition series. Now, if you look closely at the sixth and seventh period of the D block, you will find few elements missing. These are after lanthanum and actinium. You will find them listed below in the F block.
And now, on to the final block of our periodic table, the F block.
The first row elements are called lanthanides and extend from cerium to lutetium. The second row elements are called actinoids and extend from thorium to lawrencium.
I am sure you have already figured out the electronic configuration for these elements.
Their atoms have s, p, d and f orbitals. So, the electronic configuration of these elements are n-2, f 1 to 14, n-1, d 0 to 1, ns2. The last electron added to each element is filled in f orbital of the n-2 shell. These two series are also called inner transition elements. Therefore, the first row of F block starts from cerium with atomic number 58. The second row starts from thorium with atomic number 90.
Now I know what some of you may be wondering. Why should lanthanides and actinides be placed in separate rows at the bottom of the periodic table? Well, it's purely in the interest of saving space and, more importantly, to keep elements with similar properties in a single row. Okay, I know you are already familiar with the terms metals, non-metals and metalloids. Let's see how they fit into our periodic table. It's pretty simple. Elements which reach a stable electronic configuration by losing electrons are electropositive elements and metals. If elements gain or share electrons to reach a stable configuration, then they are non-metals. As you can see, metals comprise more than 78% of all known elements on the periodic table. These include elements in the S block, D block and F block, which lose electrons to acquire an octet. In contrast, non-metals are located at the top right-hand side of the periodic table. Elements in between metals and non-metals have properties of both metals and non-metals. These elements are called metalloids. The table clearly reflects a trend along its horizontal rows. As we move from left to right, the tendency to lose electrons reduces. This means
that as we move to the right, elements gain electrons. This change is gradual and passes through an intermediary phase of metalloids. It's now time to take a call from one of our students who has got a question for me.
Hydrogen is a non-metal. Why is it so?
Excellent observation. Hydrogen is a unique element with one electron present in the s orbital. It gains an electron when it combines with metals. So hydrogen can act as a non-metal.
You should know that the doubt my young friend just asked about is also a probable exam question. If you want to know about others like this one, then take a short break and join us for our next segment, Exam Decoded. Welcome back. In this episode, we have been exploring the big house of elements, that is the periodic table. Before we see what kind of exam questions you can expect, let us summarize what we have learned so far.
We saw how a large number of elements known to us can be classified in 4 blocks of the periodic table, that is S, P, D and F blocks. We studied the general electronic configuration of elements in each block and identified the position of metals, non-metals and metalloids in the periodic table.
Now that our concepts have been refreshed, let's move on to Exam Decoded. Looking to ace your exams? You have come to the right place, because Exam Decoded tells you what and how to prepare for those all-important chemistry finals. As always, I have a fun game to get us started. I am talking about the rapid fire round. The rules are simple. I'll ask you 5 questions from today's topic. You have to answer them in maximum 5 seconds. For every right answer, give yourself a mark and a pat on the back. So let's begin and pay attention to this statement. Halogens belong to S block elements. True or false? The right answer is false. They belong to P block because they have an electronic configuration of P5. If you got that right, give yourself a mark. Next question. Alkaline metals belong to P block elements. True or false? The correct answer is false. Alkaline metals are S block elements. I am sure most of you got that right as well. Here is one more where you've got to identify the truth. Lanthanide series begins from atomic number 53. True or false? If you have identified this one to be a false statement, then congratulate yourself and add another one to your kitty. Your 4th question. The element with electronic configuration 1s2, 2s2, 2p6, 3s2 is a metal. Am I right or wrong? What is your answer? Your 5th and final question is, which of the following represents the electronic configuration of group 15? A. 2s2, 2p6, B. 2s2, 2p3, C. 2s2, 2p5, D. 2s2, 2p2. The right answer is option B, 2s2, 2p3. If you have got all your answers correct, then give me a high five, because you are our topper high flyer. If you have scored 4 or 3 points, you are an achiever, but a little bit more revision won't hurt. Anything less than 3 and you are a learner. But don't be disheartened. all you need to do is to log on to www.topperlearning.com, where you will find lots of practice tests to boost those scores. The topic we are discussing today is from the chapter Classification of Elements and Periodicity in Properties. It carries a weightage of 4 marks in your exam, and this makes it an important constituent of your overall exam preparation. From it, expect short answer type questions of 2 and 3 marks in which you can score easily. But what ability will you be tested on? Well, you will mostly get knowledge ability type questions. Knowledge ability questions test how much information from the chapter you have successfully retained. Probable questions from this topic can be based on the characteristics of S, P, D, F block elements. A typical question for 3 marks and average difficulty is: justify the position of hydrogen and helium in the periodic table. Another knowledge ability question you could get is: why are S and P block called representative elements? This is a 2-mark question of high difficulty level. Let's try and answer this question and see how we can get full marks for this one. The answer basically has 2 parts. First, we'll define the electronic configuration of S and P block elements. As we have already learned, only the outermost valence shell of these blocks is incomplete. We then have to relate this configuration to trends on the periodic table. Therefore, if the nth shell is incomplete, the elements will show a regular pattern in properties in a group. What else do you need to tackle exam questions in this topic? Let's ask the expert.
Based on the type of subshell occupied by the valence or last electron, the periodic table is divided into 4 blocks: S block, P block, D block and F block. Periodic table contains 18 groups and 7 periods. Students, it is important to note that number of groups in a block is equal to the number of maximum electron that can be occupied in the respective subshell. Very frequently question has been asked in which atomic number is given and you are supposed to find out the group number and the period number. It is difficult to remember the whole periodic table, but by making some sentences we can remember the elements present in the group. For example, in group 18 we remember helium, neon, argon, krypton, xenon and radon by making a sentence like Hini or Kiran taxi se ravana.
Alright then, we have covered the length and breadth of the periodic table today. That's no small feat, especially since newer and newer elements are being added to it every day. Which reminds me of what happened in a chemistry class that I was teaching. We were discussing the periodic table and I said to the students, when I was your age, I knew all the chemical names and atomic numbers by heart. That's when I heard a voice from the back benches. But sir, there were so few elements to remember back then. Well, that may be true, but the chemistry behind the periodic table is still the same. And as long as you have chemistry to guide you, you will never be lost. So take care and see you next time.